Hello, my name is Bob Evans and today I am going to tell you everything you need to know about building a flood defence wall. It's not a great day when your property gets flooded. The first thing I do when I am asked to look at a flood defence wall is to study a Google Earth map to obtain the precise location of the property and then obtain the flood risk map. This gives me the direction and extent of flooding. The information is easy and free to obtain. The next thing is to understand how a flood defence wall works structurally. We design the wall to overcome all the failure modes on this page. The majority of them are the same as retaining walls except seepage and piping. It is important we stop piping. This occurs when water is allowed to flow quickly under a foundation and remove the fines and granular material. This will cause the foundation to collapse. To stop this from happening, we design a stop wall or downstand. You will see this later. We have supported many people to build flood defence walls and have developed a process to remove the complexity. The process is planning, design and construction project management. The planning phase, obtaining local flood maps, a Google Earth map and spot levels to help determine the wall's layout and height. Carry out a soil investigation and record the findings to determine the ground pressure. Carry out a utility search to find the location of all underground services, including gas, electric, telephone and internet cables. Carry out a manhole survey to find out the depth and location of all foul and surface water drains. Draw a plan for the wall, including dimensions, openings, services and ground levels. Design the foundation for depth and type using the soil and wall height data. Create a fully priced bill of quantities to give an accurate budget using the foundation and wall plan. Create a design brief for the structural engineer by pulling all the relevant information into one file. Use the soil investigation data to design the sump pump sizes and layout. Ensure the finance is in place, including any grants that may be available before starting the construction phase. Let's look at some of the elements to explain them. The site investigation is important to obtain the soil data we need for design. A professional site investigation can cost between £3,000 and £5,000. I will show you how to carry out a simple site investigation for £50. Buy a 150mm diameter hand auger like the one shown on this image and drill a hole 1 metre deep in locations we will agree. Take samples of the soil, measuring the depth and any soil changes. Take photographs of the soil. Take a sample of the soil and squeeze it in your hand and describe what happens and take a photograph. Even better, video it. The images here are a client carrying out the field test. We use this information to determine the ground bearing pressure of the ground for the design calculations. Porosity test. The holes that you've just drilled using the auger, fill them with water and leave for 10 minutes. After 10 minutes, fill the hole again and note the time. Describe what happens over the next few hours. If water remains in the hole, what depth is it when the water settled and became stable? If the water drained away completely, how long did it take to drain away? We will use this information for the pump design later. Site survey. We will need to draw the wall on a map. I normally use Google Earth to do this as it has a very accurate measuring function. The example on this page uses a topographical survey. On complex projects, a topographical survey is required. A topographical survey can cost between £2,000 and £5,000. If we only need spot levels, you can do this yourself for about £100 by hiring a dumpy level and I can show you how to use it, or you can find a local builder to do it for you. You can see the importance of spot levels in this sketch, as you can see how the foundation follows the falls in the landscape. This is a farm in Cumbria I am currently working on. It shows a Google map with the wall plan and ground levels. We can then work out the height of the walls when we know the flood wall design height. We determine the flood wall height using historical flood levels and adding a margin for future increased risk. The next step is to design a concept for the foundation using the soil data and the site survey information. You can see we have many variations for gravel, sand soils, clay soils and methods of construction, including glass walls. These will be discussed to ensure we select the right design for your project. An important item to get right at this stage is the project budget. Now we have enough information to produce a fully priced bill of quantities to give an accurate budget for your property at risk. The final thing we need to do during the planning stage is to pull all the information together for the structural engineer. The structural engineer will carry out the structural design and deliver a structural report and specification with a drawing showing a section through the wall and the calculations. Construction and project management phase. Adjust the bill of quantities using the structural engineer's design. Create a working drawing for site construction. To place orders, create a shopping list that includes the steel reinforcement bar schedule, reinforcement spaces and blocks, concrete mixes with quantities and the step-up block quantities. Produce a tender document to go out to tender to obtain competitive prices to build a wall from local contractors. Assess the tender prices to ensure the right contractor is selected for best value. Create a time plan bar chart for buying and on-site production to build the wall. Monitor on-site works to check the work is being carried out to the structural engineer's specifications. Value the work to pay the contractor the correct value without overpaying. Let's look at some case studies. The first one is Nick Lupton, who owns Pixham House. Nick was featured on the BBC News as his flood defence wall has become a standard. On this slide you can see Pixham House before and after the wall was built. This is a flood map for Pixham House. It is in a Zone 3 area, high risk. The ground condition at Pixham House was gravel and sand. This means water will seep under the foundation and a pump sump is required to pump the water over the wall. A drainage system is designed with the wall for this purpose. The next two slides show the wall being constructed, including excavation, steel reinforcement, concrete, the first course of blocks and the stepped foundation. On this slide you can see an opening within the wall protected by a floodgate, water being pumped out, the sump chamber and some construction images. The next case study is James Fisher from World's End. Again you can see the property is in a Zone 3 high risk location. We supported James through the whole process, including site investigation, site survey, budget costing, design and construction project management. On this slide you can see the foundation, steel reinforcements and the concrete being poured in the foundation using a concrete pump. This slide shows the first layer of blocks having been laid. And this slide shows the wall built and waiting for the concrete core to be poured. The weather was very poor while James was building the wall. It is better to build flood walls during the drier months. Unfortunately, the weather beat James before the wall was finished and flooded the site. Timing is everything. The next step. Tell us about your project. You can complete the form on this page. We are here to support you through the process. It is complex, but we can go through it step by step. Thanks for watching. Bye for now.